All right, so let's continue on with learning targets 7 through 9 video. And this is going to deal with the metric system, metric conversions, and also converting English to metric or metric to English measurement units. So a system of measurements, okay? So with the system of measurements, we're going to look at the English system, which is what we use here in the United States, versus the metric system, which is what a majority of the world uses and what is also used in the science community. So the English system, like I said, is a system that we use here. Is not used in science because there are too many conversion rates. It's not a simple conversion, as you'll see here in just a little bit. So the English system is only used in the United States, Liberia, and Burma, and you can see those countries in red. Those are the only 3 countries in the entire world that use the English system. So some examples include feet, yards, gallons, and there's many others. So the metric system is widely used in science. Conversions are simple because they're most of the time all multiples of 10 and is used by most of the world. So in this picture, the countries that are in green are the ones that are going to use or do use the metric system. So the International System of Units, or also known as the SI units, is the modern version of the metric system. Right? So this is what we're going to spend a lot of time working with virtually and when we get back in the classroom. So the SI unit for mass, okay, mass is a measurement. So the SI unit for mass is kilogram, okay, and is the unit that measures the amount of something. Okay, so mass is the unit that measures the amounts of something, and the base unit is kilogram. And here you have the word spelled out and the abbreviation. So mass versus weight. All right, so we need to briefly talk about these two vocab terms. So weight is a measurement of the force of gravity acting on an object. Mass is the same regardless of gravity. Okay, say that again. Weight is a measurement of the force of gravity acting on an object. Mass is the same regardless of gravity. So my mass is the same on Earth, and it would be the same on the moon, and it would be the same on Mars. You get where I'm going with this. However, my weight is going to change based off the amount of gravity working on my body. Right? So on Earth, you have one specific type of gravitational force working on you. On the moon, it'll be a little bit different. Mars, it would be different. So your weight is going to change. Okay, so that's the difference between mass and weight. All right, so the measurement for length. Length is how long something is, and the base unit in the SI system for length is meter. All right, so measurement of time. The base unit of time is second in the SI unit, or SI system, sorry. Temperature. Temperature is the amount of heat an object has. So the base unit of measurement for temperature is Kelvin, or capital K. The interesting thing about temperature, and I normally like to really kind of open up the floor for discussion on this one in class. You may know this and you may not. With temperature, cold is not actually a thing. Okay, cold is more of a man-made term to describe something. Is in comparison to actually being scientifically factual. When something is, and I put in quotation marks, cold, it just simply has a lack of heat. Okay, heat, and we'll talk about this as we move through this course. Heat is the most common form of energy. It's very disorganized, and it can't be used by a lot of different living organisms. But so when you say something's cold, actually what you're saying is it has an absence of heat or it has an absence of energy. So temperature is the measurement of the amount of heat that an object has. So concentration is the amount of something in a particular volume, and the unit of measurement for concentration is a mole. The abbreviation of mole is you just take the E off, MOL. All right, so area. Okay, area is length times width, and then the unit of measurements is always squared because you're multiplying two different measurements together. Okay, so it's like meter squared or kilometer squared or centimeter squared. Okay, volume is length times width times height, and so the volume is always cubed, right? Because you're multiplying three different units of measurements together. So density, okay, we're going to work with density as we move through this course as well. So density is mass divided by volume, or D equals M over V. Right? It's measured in kilograms per meters cubed. Precision versus accuracy, two important vocab terms. Accuracy is the closeness of a measurement to the true, I should say true value. Let me change that right now. Sorry. So it is the closeness of a measurement to the true value. In shooting a bow at a target, an accurate shot hits the center. Precision is the closeness of a group of measurements to one another. In shooting a bow at a target, precise shots are closely grouped together. One can be both precise and accurate. It is possible to be accurate and not precise, or precise and not accurate. Right? So this one is accurate and precise. Right? We're right on the bullseye and they're all there. Okay. Um, I would consider this accurate but not precise. Okay. This is not accurate but precise. And I would consider this neither accurate nor precise. All right, so metric conversions, right? In your pacing guide, you're going to have a link, and I'll also put it in the assignment on Google Classroom for a conversion chart that's going to look like this, okay? There's two different ways when we do metric conversions that you can do this, okay? If you're a math-oriented person, you might like doing multiples of 10, and that's okay. We'll go over that. Or if you're like me, you like going down the number line or the metric conversion ladder and moving your decimal, okay? All right, so for this, to use this chart, okay, I always remember King Henry doesn't usually, for units, space units, drink chocolate milk, okay? Now, it goes on to micro and nano and giga and mega. That's a different world, and we'll get to that later. Right now, we're just going to focus on the multiples of tens, which is what all these are. So to convert to a smaller unit, you move your decimal point to the right, or you multiply by 10. To convert to a larger unit, you move your decimal place to the left or divide. Okay, so if you're moving to the left, you're dividing. If you're moving to the right, you're multiplying. Okay, by tens, or you can just move the decimal however many spots and play Frogger. I'm going to put another video underneath this one where I do two practice problems so that you can kind of see what I'm talking about with moving the decimal. Okay, so kilo, hecto, deca. Okay, deca is symbolized by DA. All right. Then you have base units, which is your meters, your grams, your liters. Then you have deci, centi, and milli. Okay. All right. So metric conversions. Base units are grams, meters, and liters, as I just said. Kilo, hecto, so on and so forth are the prefixes. Okay. And these are prefixes to the base unit to denote their proportion compared to the basic unit. Each step represents a multiple of 10. So for example, a kilogram is 10 times 10 times 10, or 1,000 grams. A gram is 10 times 10 times 10, or 1,000 milligrams. When going from larger units to smaller units, you multiply by 10 for each step. When going from smaller to larger, you divide by 10 for each step. Now, last one here, when it talks about metric to English conversions, you'll have to have a conversion sheet. Okay, most of us have to have a conversion sheet. They're not hard to find. I'll give you one. You can find them on the internet pretty simply or pretty quickly. They're in books as well, but it's not a simple measurement or a multiple of 10. All right, I'll do some of these on the video. I'll post right underneath this link. All right, so here's an example of a metric to English conversion chart. Okay, so it tells you, 1 liter is this many quarts and so on and so forth. And what I want you to notice is how It is not a nice, pretty, even round numbers. Okay, this is why English system is not used in science, because these are some very complex um, conversions. So graphs, okay? When you have data, data needs to be reported and organized in certain ways. So we'll talk about the four different types of graphs. Bar graphs is used to count things and make comparisons between things. In this class, we're not going to use bar graphs unless I tell you otherwise. Line graphs. These are used to track progressions of changes over time. We'll use line graphs quite a bit, and this is used in our experiments. A pie chart is used to compare parts of a whole, and then a scatter plot is used to determine the relationship between two things. And we'll do more work with graphs in the next couple of days. So this is the example of a line graph. Now you can see we're tracking different things over a period of time. This is a scatter plot. And the only thing I don't like about this particular scatter plot is it doesn't have a best fit line. So a best fit line is a line that you would draw right down the middle of the, let me go back, sorry, data points to try to get the same amount on each side of the line. This is the bar graph. Most of you are probably familiar with bar graphs and pie charts, okay, or pie graphs. And so those are the four different types of graphs. Data tables, very important. Okay, we need to learn how to be able to organize data in very organized tables so it's easy to present. Okay, so these are used to help organize any data set. It gives meaning to numbers, so to speak. Numbers are just numbers unless you tell an individual what those numbers mean. A data table helps you in providing that information. Mean, median, and range. Just a couple of vocab terms. The mean is the average of a group of numbers. The median is the middle figure of a group of numbers. And the figures must be put in order to find this. And the range is the amount between the high and low figures of a group. And that is where we will end. So be sure you catch the example video that's right underneath this link, and then be looking for the video form that is also on your pacing guide for this one. And as always, if you have questions, please let me know.